Okay, so on Thursday we learned about negative exponents, and on Wednesday we learned about multiplying and dividing exponents and powers of 0. So now we're going to kind of start putting some of that stuff together. So let's start by talking about raising a power to a power. So if I look at this just like it is, 3 squared to the third power, if I expanded that, I would have 3 squared times 3 squared times 3 squared, which means if I use my rule, which says that when I have exponents with the same base, and I'm multiplying them, I add the exponents. So that would mean I would have 3 squared will be 3 times 2 plus 2 plus 2. Again, remember, because my rule for multiplying says that when I have the same, so my rule for multiplying is that if I multiply them, I add the exponents. So here I'm adding those exponents. Well, 2 plus 2 plus 2 is 2 times 3, which is 6. So what did I actually do with those two numbers? I took 2 times 3. So when I have a power raised to a power, I multiply. Let's try that again to see here if it works. Here I have 2 to the third to the 6th. So that means I have 2 to the third 6 times. So that's 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3. So how many 3's do I have? 6. 2 to the 3 times 6 is 18. I want you to try that with the next two. So take a minute and try that with the next two, and we'll see if we wind up getting the same answers. Okay, so you should have this. This is what you should have filled in. Okay, so you should have 2 times 2 times 2 times 2. So x to the x squared times x squared times x squared times f times x squared, which means 2 plus 2 plus 2 plus 2, which is the same as 2 times 4, which is x to the 8th. Same here. You should wind up with 4y to the 5th, which is y times 5 plus y to the 5th plus 5 plus 5 plus 5, which is y to the 5 times 4. You kind of see what I'm saying here. Okay, so what do we notice about that? And I kind of said it before. What do we notice about my original, my simplified form, and my original? What am I doing to get that? Okay, hopefully what you said was that I multiplied the exponents. Okay, now, how is this different from what we did before? Well, this is not 3 squared times 3 to the third. This is 3 squared raised to the third power. So that means I'm writing 3 squared 3 times. So 3 squared, 3 squared, 3 squared. So when I actually expand this out, it looks different. So if instead I had like this, 3 squared times 3 to the third, then I would use this rule here. Then I would use this rule, okay? But since I have this power raised to a power, I have to multiply through that rule. So let's check this out and see if it works. So let's simplify 2 to the 3 to the 5th. Okay, so that would be, so let's just put 2 to the 3rd to the 5th in our calculator. So I'll put that in my calculator. Okay. 2, well, it has to be in parentheses. 2 to the 3rd, whoopsie, to the 5th gives me 32,768. Holy smokes. 32,768. Now, if I were to simplify that and multiply it through like we did up here, 5 times 4 gives me y to the 20th, x to the 2 to the 4th gives me x to the 8th. That would give me 3 times 5, should be 2 to the 15th. So let's put that in our calculator. 2 to the 15th gives me the same exact answer, 32,768. Okay? That's not supposed to be smaller. I don't know what happened there. Okay, so when we raise a power to a power, we multiply the exponent by the exponent of the base. Okay? So let's try these. I want you to try this right here. Should be a plus sign. I'm sorry, that should be a times sign. So that should be times. Okay. So I want you to try those. Try those down there and we'll see what you get. Okay, so for this one, I should have 4 times 3, which is 2 to the 12th. This one should be negative 2 times 3, which is m to the negative 6. Remember, a negative 6 is never a completed answer. So does it stay or go? It has to go down to the bottom to become positive. What about this one? A to the m times n equals a to the m n. Okay? All right. I need you to practice these problems. I think you know what that means, but I don't know, maybe you don't. So I need you to do these problems and bring them in tomorrow. Okay. Now, this is a whole lot of examples of what happens when we raise a quotient to a power. But what I'm going to do to help you out with this is I'm going to let you read that on your own, but really what we're doing here is we're combining all of our rules. And it's about grouping. So the way that they write it is they expand it, but that's not how, and you can do it that way. You could expand 4x squared y, 4x squared y, 4x squared y. You could expand it and then put it back together. Let me show you how I do these problems, okay? So when they say 5x squared, what I do is I give every single thing inside the parentheses its very own set of parentheses that are squared. So I have two different things. So I have two different squared parentheses, okay? So the 5 goes in this one, the x goes in this one. 5 squared is 25, x squared is x squared. Okay, let me show you that again. Okay, so this one would be, what kind of parentheses am I going to have this time? I'm going to have to the third power parentheses, and I have 1, 2, I have a negative number and I have an n, so I'm going to have two sets of to the third power parentheses, negative 4 to the third power, n to the third power. Now, when I put this, remember, I'm going to put exactly what I see in my calculator. Negative 4 to the third is negative 64, okay? Negative 64, n to the third, okay? I want you to try this one. In this case, you'll have 1, 2, 3 sets of parentheses. One of them will be raised to the third power. Okay, so I have 1, 2, 3 sets of to the third, that's a 3, third power parentheses, okay? The first one is 2 x squared y, okay? So 2 to the third, if I put it in my calculator, 2 to the third power is 8. Oopsie. So I have 8 x squared to the third. What does my new rule tell me to do? The new rule that we just learned says that when I have a power to a power, I multiply them. So that's going to be x to the 2 times 3, which is x to the 6th, y to the third. Okay? And we're going to do more examples like this tomorrow, don't worry. Okay? Now, same thing with this. Okay? So with this one, I'm going to write a fraction, and everything in the fraction, everything in every position of the fraction gets those parentheses. So up here I have fourth power parentheses, fourth power parentheses. The top has an r, the bottom has a t, so it's r to the fourth, t to the fourth. Okay? Let's look at this one. I have 4x and 5. So up on the top, I have 2 square parentheses, and on the bottom, I have 1, because I have 1, 2, 3 different things. Okay? So I have 4 here, x here, 5 there. 4 squared is 16, x squared, over 5 squared, which is 25. That's my answer right there. Okay? Let's try this one. Same thing. Actually, why don't you guys try this one? Okay, so I have 1, 2, 3 to the third power parentheses. So I have a 4 in here, a c in here, and a d to the third in there. Okay? 4 to the third, I don't know what that is. Let's see what my calculator says. 4 to the third is 64. So I have 64 c to the third. D to the third to the third is d to the 3 times 3, which is d to the 9th power. Okay? So again, on these notes right here, when raising a product of numbers to a power, I raise each, what? You know what? Here's what it is. I raise each individual part. So each product and divisor and dividend, every single piece gets its own set of parentheses that have the same thing. We'll talk about this tomorrow. Okay, I have good good set of instructions. So don't worry about this part down here. But what you're going to do is you're going to take each individual part. They each get their own parentheses with whatever exponents outside. They get their own set of parentheses, and then you work each part individually. Okay, so tomorrow in class we will talk about more of these problems, and we will do as many examples as you need me to. So make sure that you do the thing that I told you to do earlier, and good luck.